Discussion on stoichiometry. What is the exact meaning of this? That we are going to calculate some of the things. Say for example, number of molecules in the given sample, number of electrons in the given sample, number of atoms in the given sample, then molecular weight, atomic weight, what is molarity, what is normality, making of solution, all these things we are going to discuss in this part. So let us proceed step by step. Question number 1. Can we measure weight of single atom? In childhood, I was aware that scientists knows many of the things and therefore they can weigh a weight of single atom. It is not possible to calculate weight of single atom because no such balance is there, and atom is so tiny that we can't take single atom in panel. We are not able to see the atom. Don't consider that through electron microscope we can observe electron. No, we can't even observe an atom, and therefore it is difficult for a person to calculate or so to find out weight of an atom. Then how we are going to determine? So the actual word is RAM, that is relative atomic mass. I am revising, relative atomic mass. So what is the meaning of that? We are considering hydrogen as a standard atom. Lightest known element is hydrogen, and therefore we are considering particular element is how many times heavier than hydrogen. For that purpose, initially we consider hydrogen as weight 1. Suppose I am saying that carbon is having atomic weight as 12. What is the meaning of that? Carbon is 12 times heavier than hydrogen. So atomic weight of hydrogen is 1, whereas weight of carbon is 12. Again I am speaking weight because these words are there in our memory continuously. But now as we are going to know much more thing about physics, we are aware that there is little bit difference between weight and mass. So whatever on earth, both concepts are same, mass and weight. But if you are going outside the earth, then mass will remain constant, weight can be changed. So here we are considering weight and mass as same because with Neil Armstrong, Edwin Aldrin, Yuri Gagarin, like that, fewer people they are able to go beyond earth. But maximum crowd, 99.9999% crowd is there on earth only, and therefore many times we are using word as weight. So here I am again considering that atomic weight. But if I want to use a scientific word, more scientific word, it is relative atomic mass, that is RAM. So what is mass of hydrogen? Initially we consider mass of hydrogen as 1. And then particular element is how many times heavier than hydrogen. So suppose I am saying iron is having atomic weight as 56. Then we have to consider it is 56 times heavier than weight of hydrogen, single atom. So like that we started considering how many time or how much time that particular atom is heavier than hydrogen atom. Now next concept, that is formation of molecules, and therefore we are aware that when atoms combine we are getting molecule. So molecular weight and scientific word relative molecular mass, so that is RMM. So this is something we are considering as scientific words. So no doubt I am telling you both RAM as well as RMM, but in general practice I will use word as atomic weight and molecular weight. Now further theory says that all atoms are molecule only. We have to consider everywhere a molecule. So monoatomic molecule, diatomic molecule, triatomic molecule, like that. But in that case weight, there is no concept of atomic weight, there is only concept of molecular weight. Now here, whatever we are going to observe, that is relative atomic mass, relative molecular mass, that is atomic weight and molecular weight. So we are proceeding after this type of discussion, we are proceeding to some of the calculative part. Now, intentionally I am not using here some technology because as a teacher, I believe strongly in writing something on the board. That is more useful. We have this type of habit. So we are going to start here. Some of the atomic weights, relative atomic masses, I am giving you first. So obviously, if I am considering hydrogen, it is 1. Science is having some sort of problem. That what we are going to determine initially, we are going to correct afterwards. So afterwards we realize that hydrogen is not having atomic weight as 1. It is 1.008. So here I would write here 1.008, or in more precise 1.0078. But forget of that. For general purpose, we are not going in the fraction if that fraction is too large. Again, I am telling for general purpose. So here we are going to discuss sort of fundamental things. We are not going to very high class knowledge, and therefore I would consider here the mass of hydrogen as 1 and not 1.008. So this is clear. Now next, immediate what I am going to tell, I am crossing out, because here we are considering this weight as 35.5. So here I would like to say this is 35.5. Why? This is all after discovery of isotopes. This topic is detailed discussed at time of nuclear chemistry. But right now I want to introduce a part. So we are going to just superficial knowledge. A same atom is having same number of proton, but may have different number of neutrons. Say for example, in case of chlorine, as its atomic number is 17, it contains 17 protons, but two mass numbers are existing prominently, naturally. They are mass number 35 and mass number 37. So at a time, mass number 35 means you are aware that 18 neutrons are there, and mass number 37, that means 20 neutrons are there. How to calculate proton, neutron, electron? Go to our atomic structure lecture. At that time we have discussed this. Only thing is that mass number minus atomic number. That will give you number of neutrons. So here chlorine is having two isotopes. One is isotope having mass as 35 and one is isotope having mass number 37. But they are having ratio as 3:1. In natural way, we are getting suppose 4 atoms of chlorine. Out of that 3 atoms are of chlorine 35 and 1 atom is of chlorine 37. So I would like to get average. So if I am calculating average, then obvious thing is that 35 3s are 105 plus 37 into 1 37. So 12 4 1. So this is total atomic weight of 4 atoms. Now I have to take average, so 142 upon 4, because we are considering here 4 atoms. So 142 upon 4, 4 1s are, 4 3s are, carry forward 2, 4 5s are, balance 2, remainder 2, we have to get decimal 24 5s are. So we are getting average atomic mass or average atomic weight as 35.5. So this way we are considering atomic weight of chlorine as 35.5. So what is here? We are considering atomic weight. It is average weight of all atoms and we have to compare it with weight of hydrogen atom, single hydrogen atom. So weight of single hydrogen atom we are considering 1. So divide this figure by 1, we are getting 35.5. Now next atom, henceforth we are going to only round figure. Nitrogen 14, then sodium 23, potassium 39, calcium 40, then sulfur 32, phosphorus 31, carbon 12. In case of oxygen, many people are having confusion whether we should take it 8, 16 or 32. The answer is atomic weight of oxygen is 16. So in case of oxygen, we have to consider this as 16. So fewer example I have given here. Magnesium, you can consider 24. Calcium already we have discussed. So some of the prominent atomic weights are given here. Again, keep in mind, the only whole numbers are given. Actual weight may be little bit here or there. But as we are going to discuss this all topics just superficially, we are giving this data. The thing is that few atomic weights are there in front of you. By using these atomic weights, how to go for calculation of molecular weights? So we are now calculating molecular weights here. Let us have simple example. We can calculate molecular weight of calcium chloride. The molecular formula is CaCl2. Now keep in mind, you should aware what is exact molecular formula. How to build molecular formula we have discussed in previous lecture. So go through that previous lecture, you will get idea that how to build molecular formula if not there. And if you are already aware, then alright, let us start. This is the thing. We are going to discuss from very fundamental level, and so I would like to make some sort of table over here. Here we have to write name of atom. So first atom I have determined calcium, second atom I have determined chlorine. So in the molecular formula only 2 atoms are there. How many atoms are there? So here number of atoms. So here nothing is written. Nothing is written means actually there is 1. So calcium 1. Then we have to go here by atomic weight. You are aware now actual word is relative atomic mass. So I should write here RAM. But here I have written atomic weight. So find out atomic weight of calcium here. This is 40. Then find out atomic weight of chlorine here. It is 35.5. But how many atoms of chlorine? 2. So 35.5. Now multiply the weights here. So 40 into 1, you will get here 40. 35.5 into 2. So keep in mind 35 to the 70. 0.5 to the 1. So 71. So here I should write here 71. Now what we have to do? We have to sum. So make addition of this. So 40 plus 71, that is 1. 7 plus 4, 11. So this is what molecular weight. So this is the number molecular weight, that is 111. Getting idea? So this way we can calculate molecular weight initially. Once you are having practice, you can calculate orally also. Want to see? Just try. Another molecule I will give here. Calcium carbonate. I will show both the method. 1 atom 40, 12. 40 plus 12, 52. 16 threes are 48. So here we have carried out 52 plus 16 threes are 48. 48 plus 52, 100. Oral. Otherwise, go by systematically. Same way we can go make table. So number of atoms. So calcium. Then carbon. So don't say CO3. CH carbon and O is separate. The next thing, number. So number is 1, number is 1, nothing is there, therefore number is 1, 1, and oxygen is 3. Now atomic weight, calcium is 40, carbon 12, and oxygen, as we have discussed, 16. And now make calculation. 40 into 1, 40, 12, and 16 3s are 48. So 8 plus 2, 10, carry forward 1, 5, 6, 6 plus 4, 10. So here I can say molecular weight, that is equal to 100. So you can go by this method to carry out calculation of molecular weight. Now I would like to give you some exercise. So first thing, carry out molecular weight of sulfuric acid, molecular weight of nitric acid, and molecular weight of hydrochloric acid. Formulas: in case of sulfuric acid, H2SO4. In case of nitric acid, HNO3. And hydrochloric acid, HCl. Let us start. Sulfuric acid. It is H2SO4. So I am writing here formula H2SO4. Let us go by two methods. First is oral and second is written. So hydrogen we are having 1, so 2. Sulfur is 1, 32. 2 plus 32, 34. And O4. So 16 4s are 64. So 64 plus 34, 98. Oral method. Let us go step by step. Number of atoms, name of atoms, so hydrogen, then calculate sulfur, and lastly oxygen. Number of atoms, hydrogen 2, sulfur 1, and oxygen 4. Atomic weight 1, 32, and 16. So it is 2 into 1, 2, 32 into 1, 32, and 16 4s are 64. Total 8, 9. So we are having weight as, molecular weight as 98. Now this way we can calculate weight for next, that is hydrochloric acid. So this is the formula of hydrochloric acid. So it's very clear, oral, hydrogen 1 and Cl1. So hydrogen 1 and Cl 35.5. So you can easily say it is 36.5. Can molecular weight be in the fraction? Answer is yes. So it is 36.5. Next formula, nitric acid. It is HNO3. Oral 1, nitrogen is 14, that means 15, and 16 3s are 48. So 48 plus 15, that is 63. We can calculate this way. Hydrogen, nitrogen, oxygen, hydrogen 1, nitrogen 1, oxygen, oxygen number of atoms 3, weight 1, 14, and 16. So 1 into 1, 1, 14 into 1, 14, and this is 48. So 5, 8 plus 5, 3, 5 plus, 4 plus 1, carry forward 5 plus 1, 6. So weight is 63. So this way we can calculate molecular weights of various substances here. So make practice of finding out more molecular weights. So find out the formula and try to make molecular weight of that particular substance. For homework, let us say, I will give you here some molecules and try to find out molecular weight of that. You may ask why this is required. I want to tell you the practice. When we are having sufficient practice, the concepts are very much clear in our mind. And just I am giving you some sort of exercise. Let me clarify again. Say for example, if you are going to a gym, a person will explain how to carry out particular exercise. Say for example, push-up. or coulombs. So he will say, explain you how to carry out that first time. And then he will say, now okay, make set of 10 push-ups you have to carry out. Like that exercises are there. So here also I am giving you same idea, same exercises here. So here I will give you list of some molecule. Intentionally I am giving you formula only. Name I am going to pronounce and you have to write. So this is acetic acid. By writing only, we'll go for information also. You are aware this is organic chemical, this is acetic acid. 4% dilute solution of acetic acid is also called as vinegar. So you are aware of Chinese food and all that, they are using vinegar. So this is 4% dilute acetic acid. This is the formula of acetic acid. Now here keep in mind, this is carbon, this is carbon. So in your exercise you have to write carbon only once, but number of atoms 2. Same way oxygen, 2 oxygens are written separately. So don't write down O, write down O and number of atoms 2. Okay, let me clarify. One more molecule we are going to discuss and then we will proceed. So number of atom, carbon, hydrogen and oxygen. Now second thing, number of atoms. So carbon 1 and 2. So write down 2. Hydrogen 3 and 1, 4. And oxygen 2. So write down this way. Now take weight 12, 1 and 16. And now proceed further. 12 to the 24 plus 4 plus 16 to the 32. You will get 4 plus 4, 8 plus 2, 10. Carry forward 1, 4 plus 2, 6. So here molecular weight of acetic acid, or it is also called as, this is called as IUPSC name, International Union of Pure and Applied Chemistry, that is IUPSC. So IUPSC name is ethanoic acid. Common name is acetic acid, and in kitchen we call it as vinegar. So this is the molecular weight of acetic acid. Second substance. This is ethyl alcohol. We can consider what different liquors, particularly alcoholic drinks are there. In that, this is ethyl alcohol, that is the essence of this all alcoholic drink. So this is ethyl alcohol, or IUPSC name. You are aware of the full form, International Union of Pure and Applied Chemistry. So IUPSC name of this substance, that is ethanol. So find out molecular weight of this. Then in food industry or day-to-day kitchen life also, this substance is really important. This is sodium chloride, that is called as common salt. This is NaOH. This is called as sodium hydroxide. But in old days, this was having name as caustic soda. The element which is extracted from soda is given name as sodium. So this is sodium hydroxide. This is potassium hydroxide, or called as caustic potash. So this is potassium hydroxide. Calcium sulfate, followed by calcium. Now here look at the pronunciation, it is sulfaide. In previous lecture also we have explained, this is called as calcium sulfide, this is called as calcium sulfate. Sodium nitrate, sodium nitrite. So this is sodium nitrate, this is sodium nitrite. this is magnesium hydroxide. What is the meaning of bracket? OH group twice over here. Here you will get OH only one, but here OH is twice. So this is called as magnesium hydroxide, or in common language it is called as milk of magnesia. Generally it is used in medicinal purpose, but this is magnesium hydroxide. Then same way we are having compound calcium hydroxide. So like that, various compounds I have given here. Little bit information about that compound is also given here, and you have to find out molecular weights. Right now your target is just to find out molecular weight of these substances. The concept that is called as gram atomic weight. Now you are aware, till here we were discussing the atomic weight in terms of relative atomic weight, that is relative atomic mass, like that. But henceforth we are considering that as expressed in terms of gram. Because say, suppose I am having 1 gram of hydrogen and I am having 12 gram of carbon, then ratio is again 1:12. So can I consider everything in terms of gram? So if we are expressing out this atomic weight in terms of gram, then we are calling it as gram atomic weight. If we are expressing in terms of molecular weight, expressing in terms of gram, then we are calling it as gram molecular weight. Or rather, I should clarify one more concept here. We are calling this as 1 gram atom. What is exactly the meaning? That atomic weight expressed in terms of gram. So 1 gram mole, 1 gram mole, that is molecular weight expressed in gram. 1 gram atom means atomic weight expressed in terms of gram. So if I am saying that molecular weight, let us check molecular weight of say calcium carbonate, that is CaCO3, that is equal to 100. You can check out calcium 40, carbon 12, 40 plus 12, 52, and 16 into 3, 48. 48 plus 52, 100. So that means number of mole, say in case of mole, abbreviation is MOL and full form is MOLE. So just I am using here abbreviation, that is 1 gram mole of calcium carbonate equal to 100 gram calcium carbonate. Getting idea? So this 1 gram mole of substance, molecular weight of that substance expressed in terms of gram, that is called as 1 gram mole of substance. You may ask question, why this concept is required? Keep in mind, we are not going in detail, or rather I should say very high class calculations we are not going, but little bit we are going. So here we can consider that when we are talking of 100 gram calcium carbonate, that is equal to 1 mole calcium carbonate, that is equal to 6.022 into 10 to the power of 23 molecules of calcium carbonate. So it's very clear now that 1 gram mole of substance, that is equal to molecular weight expressed in terms of gram, that contains 6.022 into 10 to the power of 23 number of molecules. This number is called as Avogadro's number. So 1 mole of any substance means this is the number of molecules. Say it is actually 1 gram mole, 1 mole. What is meaning of 1 mole? It is something like 1 dozen. When I say 1 dozen, that means 1 dozen, that means 12 pieces. So same way 1 mole, that is equal to 6.022 into 10 to the power of 23 number of particles. Whatever the thing, say atoms, molecule, electron, proton, anything. So now this expression gives clear idea that first find out molecular weight of molecule, you will get that. Then 1 gram mole of substance equal to molecular weight expressed in terms of gram, that is containing, this is the number of molecule.